Imagine a cosmic symphony played by an immeasurable number of stars, planets, and moons all playing in perfect harmony. However, there is one particular section of this orchestra that has perplexed astronomers for centuries. Exoplanets are natural planets. They are worlds that exist outside our solar system, hidden deep in the Milky Way. You might be surprised to learn that among the vast number of cosmic objects, they're an exoplanet so similar to Earth, so tantalizingly similar but enigmatic, that it could be our planet celestial twin. We dwell into the fascinating realm of Proxima b, located just 4.2 light years away. The James Space Telescope is revolutionizing our search for an understanding of these celestial enigmas. Imagine a moment that your mind travels across the vast astronomical realm of our galaxy, the Milky Way, which is home to more than a quadrillion exoplanets. That's one with 15 zeros to put this number in perspective. If each of these exoplanets were the size of a grain of sand, we would not only fill the Gray Canyon, but we would have enough to create a new geological monument on Earth, a Grand Canyon 2.0 that would stretch 4 miles. What is most surprising is that about 20% of these celestial bodies have been classified Earth-like in terms of geological and atmospheric structure. That means that there is a 1 in 5 chance of finding a twin of our planet, and the story doesn't end there. Along with these planets, there could be another quadrillion moons, rocky satellites similar to our moon, locked in gravitational dances with their parent planets. If you were to be on the possibility of discovering another body in space that harbors life, or could do so, the cosmos offers an abundance of opportunities. Now that we have unfolded the canvas of cosmic scale, it's time to introduce the master artist equipped to paint its intricate details, the James Webb Space Telescope. This celestial Sherlock Holmes with its magnifying lens, replaced by telescopic lens, outperforms even the most advanced smartphone optics. We're not talking about just any lens. Its 6.5 primary mirrors, it's 2.7 times larger than Hubble's. Imagine the finest it can detect even in the faintest flicker of a star billions of light years away, and then analyze the details of orbiting planets. What makes the James Webb Telescope revolutionary isn't only its observing power, but also its advanced technology, and including infrared sensors and spectrograph. These tools can do much more than observe. They can analyze and filter the unique light signatures emitted or reflected by celestial objects to decipher their atmospheric condition, composition, density, and even mass, acting as a space forensic. And they can determine whether a planet has water, organic compounds, or even oxygen. The James Webb Space Telescope has the ability to answer these questions, elevating it from a mere observer to an analytical genius. It's not just an advance over its predecessor Hubble, it's more like a quantum leap. If Hubble's discovery surprised you, get ready for viral feast of celestial revelation. Just as we bring our gaze across our complex landscape of cosmos, is worth focusing on one particular star in the celestial show Proxima b. Since his discovery in 2016, this enigmatic planet has stood out as Shakespearean protagonist, full of complexity and paradoxes, captivating astronomers and anthropologists alike. What's all the fuss about for stunters? Proxima b is practically in our cosmic neighborhood, shows 4.2 light years from Earth. To put it in perspective, if you could beat the universal speed limit and travel at the speed of light, you get there in just over 4 years, about the same amount of time it takes for your favorite TV show to fall into decay, or a presidential term. But let's dig deeper into why this proximity is so important. We're talking about a universe that stretches over 93 billion light years from end to end, so finding a planet so close and so promising for scientific research is like finding a diamond in a pill the size of Mount Everest, a diamond that potentially holds secrets about life itself. In the grand tapestry of the universe, Proxima b is an intricate stitch, offering us invaluable clues that could redefine our understanding of habitability and life beyond Earth. It's not only Proxima b's proximity to Earth that excites the scientific community, but also the tantalizing clues that this planet is that only Earth-like, but possibly Earth 2.0. Proxima b sits comfortably in what astronomers called the habitable sun or Gillick zone of its parent star, where conditions are neither too hot or too cold, but just right for liquor water to exist. Imagine waterfalls, mandarin rivers, vast lakes, and perhaps even oceans as deep in and mysterious as the Mariana Trench. But before we start dreaming about vacationing in Proxima b, let's consider some of the specularities for Starters a single day on this intriguing Exxon planet lasts a staggering 11 days. Imagine sunrises that not only herald a new day but unfold slowly resisting, giving away to midday, and sunsets that stretched out too long creating golden hours that photography first dream about. While it sounds idyllic, it also has significant implications for its climate and habitability. How would human biorhythms adapt to the cycles of light and dark on Proxima b? We would need to eat 3 times or 4 times as much in a single day on that planet. Would we sleep the same way on this very different world? The fundamental patterns of life as we know it would be at once tantalizingly similar and disconcertingly strange. It is as if nature is presenting us with a riddle wrapped in a conundrum, testing our understanding of what makes a planet habitable. You may wonder how we can obtain accurate and reliable data about world we have never visited. The J Space Telescope deploys all its capabilities like a cosmic Swiss Army knife. More than just a telescope, it is a multifaceted research laboratory in the vacuum of space. Thanks to its innovative technology, astronomers not only observe planets but examine them through a prism of analytical tools that would make CIS labs look rudimentary. Using advanced pictographs, the Webb telescope can analyze the light emitted and reflected by these remote planets. Each element or compound in a planet's atmosphere absorbs or emits light at a specific wavelength. By studying these patterns, scientists can perform a remote biopsy of celestial bodies, determining not only atmospheric pressure and density but also the possible existence of compounds essential to life such as water, organic carbon molecules, and even oxygen. It's not just astronomy, it's space forensics. We don't wait passively for clues to come to us, we actively search for them, analyzing the atoms and molecules that make up these antic worlds. The Webb telescope